The energy that comes from the sun is what heats the Earth. This solar radiation controls the temperature of our atmosphere. From space, we can see sunlight spreading across the Earth, giving life to everything. The surface of the Earth absorbs heat from the sun and then passes that heat to the air above. Through conduction, convection, and turbulence, the lower air becomes warm. That is why the atmosphere is heated from below and not directly by the sun. If we look at the globe, sunlight falls directly on the equator. That is why it is hotter there. At the poles, sunlight strikes at an angle and less heat is received. Where the day is longer, the surface gets more time to heat up. In summer, the days are long and temperature becomes high. In winter, the days are short and the surface remains cooler. As we go higher in the atmosphere, temperature decreases about 6.5 degrees per kilometer. Mountains are always cooler than plains because the air density is lower and it absorbs less heat. Land and water absorb heat in different ways. Land heats up quickly and cools down quickly. Water heats up slowly and cools down slowly. That is why coastal areas have a moderate temperature. Clouds reflect some of the sunlight during the day, making the day feel cooler. At night, those same clouds trap heat and make the night warmer. On clear nights, the ground loses heat quickly and becomes cold. On mountains, the south-facing slopes receive more sunlight and stay warmer. The north-facing slopes get less sunlight and remain cooler. Ocean currents also affect temperature. Warm currents make coastal regions warmer. Cold currents make them cooler. The direction of the wind changes the temperature. Warm winds from the south raise the temperature. Cold winds from the north reduce it. In the troposphere, temperature decreases with height. This is called the normal lapse rate. The average lapse rate is 6.5 degrees per kilometer. Sometimes the temperature increases with height. This is called inversion. It creates stable conditions and prevents air movement. On a clear night, the ground loses its heat to space. The surface becomes cool while the air above stays warm. This forms a radiation inversion mostly found in valleys. In a high-pressure area, air sinks and becomes warm as it is compressed. This warm layer sits above a cooler layer. This process is called subsidence inversion. When warm air passes over a cold air mass, it forms a frontal inversion. This temperature difference can create clouds and fog. During inversion, visibility can become very poor. Pollution and fog get trapped near the ground. In aviation, this creates stable air and possible wind shear conditions. Temperature changes through the day. Just before sunrise, the temperature is lowest. It reaches maximum around 2 in the afternoon. Then it slowly decreases again during the night. Temperature also changes through the year. In summer, the sun is higher and the days are longer. In winter, the sun is lower and the days are shorter. Near the equator, this change is very small. Temperature is measured in 3 main scales: Celsius, Fahrenheit, and Kelvin. The freezing point is 0 degrees Celsius and the boiling point is 100 degrees Celsius. To convert, Celsius equals Fahrenheit minus 32 multiplied by 5 by 9. Kelvin equals Celsius plus 273. According to standard atmosphere at sea level, temperature is 15 degrees Celsius. Pressure is 1013.25 hectopascal. Density is 1.225 kilogram per cubic meter. These are the base values used in aviation calculations. So now we understand what factors affect temperature, how the atmosphere gets heated from below, how lapse rate and inversion influence flight conditions, and how standard values give pilots a clear reference. Understanding temperature is essential for every aviator because it directly affects flight performance and weather.
Like, share, subscribe to Garuda classes.